So now you can see from this example, if the two angles are coterminal, their measures just differ by an integral multiple of the 360 degrees. So this is an important property about the coterminal angles. So now, if we have the two angles alpha and beta in the standard position, okay, and if they are coterminal, this holds if and only if we have the one integer, so this symbol means there exists an integer k such that the measure of beta minus the measure of alpha is equal to this integral multiple of the 360 degrees. So there is a k times 360 degrees. So if you have the two angles and you need to tell if they are coterminal, you may just get the difference of their measures to see if this difference is an integral multiple of 360 degrees. And you can also know adding two rays with the same vortex, they just represent the infinitely many different coterminal angles, right? So actually, you just rotate one more revolution, you get another angle which is coterminal with the negative 90 degrees, right? So now, let's look at the one problem. Let's go to the page 429. And let's look at the problem 3. We need to find the two positive angles and the two negative angles that are coterminal with the given angle. So our given angle is the negative 16 degrees. Now let's come back to the whiteboard. So it's page 429, problem 3. We have a given angle which is equal to negative 16 degrees. So right now we need to find the two positive and two negative angles which are coterminal with this given angle. We know any angle which is coterminal with this given angle can be expressed as negative 16 plus k times 360 degrees. Actually, let's go back to the last page. You see here, I say alpha and beta are coterminal if and only if their difference is equal to k times 360. So right now, we may use alpha to express the beta. So we have the m of beta equal to m of alpha plus k times 360 degrees, right? So right now, the m of alpha for this problem 3 is equal to negative 16 degrees. So right now, the beta can be written in such a form. So now, first, if we want to get the two positive angles, we may net k equal to 1 and 2. So we net k equal 1 and 2. Then we get the two positive angles. So now we have the two positive angles. So first one is k equal to 1. You have the 360 degrees minus 16 degrees, and which is equal to 344 degrees. So 344 degrees is coterminal with this negative 16 degrees. Another one is 2 times 360 degrees minus 16 degrees. Then you have the 720 degrees minus 16 degrees. Then this is equal to 704 degrees. 704 degrees, which is also coterminal with this negative 16 degrees. Now, we let the K equal -1 and -2 to get the two negative angles which are coterminal with this given angle. So now we have the two negative angles. So first we have the K equal to -1, so we have the negative 360 degree minus 16 degree, and then we get the negative 376 degrees. And we have the K equal to -2, we have the -2 times 360 degrees minus the 16 degrees. Then we have the negative 720 degrees minus 16 degrees. Then finally we get negative 736 degrees. So in such a way, we find the two positive and two negative angles which are coterminal with this given angle. Now, we have another type of questions. If we have two angles, how can we tell if these two angles are coterminal? So now let's go to the problem 6. Right now we have these two angles, 744 degrees and negative 336 degrees. Then we need to determine if these two angles are coterminal. So let's come back to the whiteboard. So this is the problem 6 on the page 429. We have these two given angles, 744 degrees and negative 336 degrees. And let's go back to that problem again. See, if the two angles are coterminal, then their difference of the measures must be equal to an integral multiple of the 360 degrees. So that means when we just plug in the measures of these two angles into this equation, in such a way, we set up an equation in K, in the unknown K. If we can solve this equation to get an integer K, then that means this holds for this integer K. Then these two angles are coterminal. If we cannot find an integer solution, then that means these two angles are not coterminal. So now let's come back to the problem 6. So now we try to set up such equation in the K, in unknown K, 744 minus negative 336. And this is equal to K times 360 degrees. And we know this difference is equal to 1080 degrees. So 1080 degrees equal to K times 360 degrees. Now we divide both sides by 360 to see if we can get an integer solution for K. So actually, K will be equal to 1080 degrees divided by 360 degrees, and this is equal to 3. So we have found an integer solution. So that means this guy is equal to 3 times 360 degrees. So this just implies these two angles are coterminal. Right? We just write the coterminal.